Woohoo! Welcome back. Today we're going to be working with two more examples of factoring, and the first one is going to be a trinomial. Woohoo! Yay! And this is a trinomial that is really interesting. Now, if you were to go into this and just say, oh, I see a trinomial, so you go through your checklist. You say, okay, is there anything common to 9x squared, 24x, and 16? And the answer is no. 9 has a bunch of 3's, well, a couple 3's. 16 has either a couple 4's or a bunch of 2's. Nothing in common there. So then what you could do is you could approach it with the AC method. And I'll remind you, the AC method, 9x squared plus 24x plus 16. A is 9, B is 24, and C is 16. So A times C, and even I'm going to have to look that one up. Let's see, A times C is going to be 9 times 16. I could probably do it in my head if I talked myself into it. Oh, what an exciting number, 144. And the good news is that everything is pluses, so we don't have to worry about negative numbers. Our B is 24, so that should be the sum, right? And so we can do 1 times 144, the sum would be 145. 2 times 72, the sum would be 74. 3 times, and here I'm going to have to go in here, I'm going to say 144 divided by 3. 3 times 48, the sum is 51. Does 4 go into it? 4 times 36, the sum is 40. We could do this. This is not the worst way to spend your life. 5 doesn't go into it. 6 times 24, the sum is 30. We're getting close. We're getting really close. Does 7 go into it? No. Does 8 go into it? Let's check. Yes, 8 times 18, which, oh, so close, is 26. Does 9 go into 144? Yes, it does, right? 9 times 16. And that's 25. Oh my gosh, we're just getting closer and closer and closer. Does 10 go into it? Nope. Does 11? Well, you can try it. 144 divided by 11. Nah, that's not it going into it. Or 12. And something interesting happens because 12 works. It's 12 times 12, which gives us that magic sum. But that should be a tip-off that something else is going on. If we get this perfect square, then that suggests that our trinomial was, in fact, a perfect square, and there was an easier way to do it. But we've already put all the time into the AC method, so I'm going to go ahead and say, okay, I'm going to use the AC method back over here. 9x squared plus 24x plus 16. I'm going to break the 24, so I've got 9x squared. The 24x is going to go into 12x plus 12x, right? So I split up that 24 into two pieces according to these two. Okay, so far so good. And then I say, okay, I've got my grouping. So what's common between 9x squared and 12x? 3x, you got it. Times 3x plus 4, I think. Take a look at that, see if you agree. 3x times 3x gives us 9x squared. 3x times 4 gives that the 12x. Okay, between 12x and 16, I got a plus here, so I bring that down. I think I've only got a 4 that's common. 12 divided by 4 gives us that 3x. 16 divided by 4 gives us the 4. And then we get very excited because 3x plus 4 matches. So our grouping works. So we've got 3x plus 4 times the quantity 3x plus 4. Oh my goodness, it is a perfect square. Now, even though this was a perfect square, the AC method will work to factor, so we can do that. But let's take a look to see what it would look like if we went ahead and just tried factoring it using perfect squares. And let me remind you what the formula is. If the pattern says a squared plus 2ab plus b squared, then we get a plus b, the quantity squared. Now, it's a lot to remember, but if you do remember this formula and you do recognize this pattern, you don't have to go through all the rest of the work. So let's take a look. I've got 9x squared plus 24x plus 16. So to fit into this pattern, we don't know for sure it does, so we would just be checking to see. We're pretending we're doing this over again. We don't know what the answer is yet. So I would look at the first one. I would say, can I write the first one as a perfect square? And the answer is yeah. That would be 3x, the quantity squared. And then I go to the last one and I say 16. Can I write that as a perfect square? Yeah, that's 4 squared. Now, what do I have to have in the middle? I have to have a 2 and a 3x. I have to have a, right? The 2 and the a. And then I also have to have a b. So I need one of each of these guys to come into the middle and a 2. What would that be? That would be 3x, quantity squared, plus 2 times 3x times 4. That's 6x times 4. It's 24x. Plus 4 quantity squared, which is 16. Does it match? It does. If it follows this pattern, if you get the right amount in the middle, you know right off the bat, it's 3x plus 4, the quantity squared, and you're done. So you don't have to mess with all of these. Woohoo. So, but will it work? Absolutely. The AC method will work. Trial and error will also work. But if you recognize a pattern, if you see numbers that look like squares, 9, 16, 4, 25, 36, right? All the numbers you know of as squares. If you see a bunch of them dancing around, check for a perfect square because it can save you a lot of work. And if it doesn't work, it only takes a couple lines and then you know, okay, it's not going to work, so I'll go look somewhere else. Okay, so that was the first one. Woohoo! I wanted to give you another example. And then I also wanted to give you an example of factoring by grouping. And this one's going to be grouping that doesn't necessarily look as pretty as the ones we've been doing. So I wanted to give you an example. And in fact, it says number 1, but I'm not going to give you number 2. I'll leave it that way. It'll just be suspense. Ooh, what would the next one be? I don't know. So what does grouping look like? Well, grouping requires that you have 4 terms. And if you have 4 terms, it is the way that you're encouraged to proceed. Once we get further in this class, you'll learn some other techniques. But for right now, you see 4 terms, grouping. And generally speaking, we're going to start by grouping the first 2 and the last 2. Most of the time, this will work. Occasionally, you have to move terms around, but most of the time it works to just group it this way. Now, in the first 2, with the 3 and the 5, I don't see anything in common. The 3 and the 5 are both prime, so that's not going to work. However, I do have some x's. I can pull out x squareds. So 2 x's get pulled out, x times x, and I'm left with, if I bring 2 of the x's here, I've got 3 x's here, so this will be 3 times the leftover x, plus, and if I take out all the x squareds, all I have is 5. Now remember the trick, there should be a minus. Bring the minus down if if there's a minus in the middle, what do these two have in common? And I'm going to factor out a 2. Now, be really careful. Because there was a minus in the middle, I'm factoring out a -2, not just 2. So when I factor -2 out of -6x, I factor out the negative, I factor out the 2, I've got 3x. Now, this is going to be a tip-off. We're aiming for this, so this will kind of encourage you to go this way. But when you're factoring out a negative, make sure you're paying close attention to the signs. If I have -10 and I'm factoring out -2, I'm dividing by -2, I have +5. And if you're ever not sure, remember you can always use the distributive property to check that you can get back. And of course, this is very exciting because, yay, these two match. The grouping worked. This is so awesome. Yay. So then I'm going to pull the x squared and the -2 together. And I'm going to pull the 3x and the +5 together. Yay. Put a big old happy box around that. Woohoo, happy boxes everywhere. And you guys are awesome. And we are done. Woohoo, dance, dance, dance. So go have some fun. Go get some, go get a snack, some hydration. Maybe get out, see a little sunshine if there's any sun out. See a little starshine if that's what's available. And, know that you are awesome and amazing and incredible. And I think the world of you. Math